Okay, today is October 17th, 2011. We're on lesson 3.5. These are the pages you are in your book. You need to know what a chord is, and along with that, you'll need to know these shapes for previous things we've done. But let's start with today's stuff. So we're going to be verifying properties of circles, and I'm just going to fix this here. There we go. Okay, this shape here is what? We have a circle. These lines are called chords. Okay. There's a couple properties that go along with a chord in a circle that will help us find the center of the circle. So the center of this circle is going to be, somewhere in this space, but we don't know exactly where it's going to be. What we're going to find out is that if we find the right bisector, okay? The right bisector of a chord. Now, that word itself gives us two different pieces of information. So, the word right refers to what angle? So, we need an angle that is 90 degrees from the bisector. What does the bisector mean? Cuts the line in half. So, to find half a line, what are we looking for? Midpoint. So, we need the midpoints of the chords. Now, I'm just kind of guessing right now, but we're going to find them mathematically after. So, we need to find the midpoints of these chords. Then I need to find the right angle line from them. So, let's just assume I'm drawing perfect right angles here. So, here's an equation of a right angle, and we'll say this is another roughly right angle. Where those two right angles cross is the center of a circle, okay? So anytime we're trying to find the center of a circle, we need to know this information. We need to know the right bisectors, okay? So to find the right bisectors, we'll go by step. We need to find the midpoints. Then the right angles from those, we'll need to find the slope of the chord. Need to find slope of the chord. Then after the slope of the chord, we'll have to get the negative. Oh, this is a word I'm not going to spell. R-E-C. Is that right? We're going to say it's right. The word is reciprocal, which means to flip a fraction. Okay? So if we have x and y, the negative reciprocal of that becomes negative y over x. We'll find the negative reciprocal, which gives us our perpendicular lines. Then finally, to find out where they cross each other, anyone know what we're going to do? We need to find the equation of the line. Equations of the right bisectors. And then when I have those two equations, because there's two lines, right? These are both right bisectors. This one here, that wasn't very well drawn, and this one here. Those are both right bisectors. How would I find where they intersect each other? I find the points of intersection. Which means I can use what to solve them? Somebody just said it, Anderson. Can use substitution, elimination, or I can graph it, but because I'm verifying, guys, I actually want mathematical proof. So I'll need you to use substitution or elimination to prove the points of intersection. The points of intersection will be the center of the circle. There are a lot of steps to this. Okay, they have given us these 3 points. These 3 points lie on a circle. So the question will be these 3 points These 3 points lie on a circle, okay? So what that means is we're going to plot these points. And after we plot them, we're going to try to figure out where the center of this circle is. That's what the question is going to ask us. Where is the center, okay? So A, where is the center of the circle? We're going to have to go through all of those steps to solve this. So point P is at 9, -3. 9 and -3. No, you'll understand what I'm saying in a minute. Okay? Q is at 8 and 6. And R is at -1 and 5. So what this question is saying, hopefully it doesn't work perfectly, but some circle goes like this, okay? And it touches all those points. So if I move this, it would almost touch all those points. We're trying to find out the center of that circle, okay? So first off, remember what we learned from before? Let's go back here and we'll go over actually, the other thing we need to find are the chords. So we're going to call this 1.5 instead of 1, because I kind of drew it in after. 1.5. Find the chords. So we have 3 points, and we know it's on a circle somewhere. We need to find the chords. How can I create the chords? Does anyone know? Connect those lines. So I'm going to connect these lines here. This is a chord. It goes from a point in the circle to another point. And I could also connect, what was the other letter? R. So I connected point R and Q. So line RQ is a chord. And let's make another chord. What would you like the other chord to be? QP?
PQ.
Same thing. So here's another chord, line PQ. Now I want you guys to make sense of this, so I'm going to draw a circle out here. Okay, so this is the hypothetical circle we have. We need to find out where the center of it is exactly. We've drawn 2 chords. From those chords, what was the first step I needed to do?
Midpoint.
I need to find the midpoint of each chord. So our midpoint formula, x2 plus x1 divided by 2, y2 plus y1 divided by 2. Okay? Now let's write down point R and Q. Point R was at -1 and 5. And point Q was at 8 and 6. So I'm going to call one of them point 1, one of them point 2. So this is 1. This will be my x1, y1. This is my second point, x2, y2. I'm going to put it into the midpoint formula. We end up with x2 is 8 plus -1 divided by 2. Y2 is 6. Y1 is 5. So 6 plus 5 divided by 2. Our midpoint, 7/2. And 11/2 is our midpoint of that chord. Okay? Let's find the midpoint of our other chord. Point P was at 9 and -3. And we know Q is at 8 and 6. Point 1, so here's my x1, y1, x2, y2. Put them into a midpoint formula. We know x2 plus x1, so x2 and x1, that's 8 plus 9 divided by 2. Y2 plus y1, 6 plus -3 divided by 2. 17 divided by 2, and 3 divided by 2. Okay, so I found the midpoints of both chords. Now, these fractions might be hard to see, so I'm going to turn them into decimals so we can make sense of them for now. This becomes 3.5 and 5.5. That's my x and y value. This becomes 8.5 and 1.5. So when we go to look at this, x 3.5, y 5.5. So 3.5, 5.5. Here's our first midpoint. We're going to call it midpoint 1. Our other midpoint was 8.5 and 1.5. So halfway up here. That's midpoint 2. Okay, the next step we need to do is we need to find the slopes. So we have our midpoints here. We need a right bisector. So we know these points are cutting these lines in half, but we now need to make the equation of a line that's going to create a right angle from there. Okay? So we're looking for the right bisector. So what that means is I have to find the slope of RQ and the slope of PQ, and then get the negative reciprocal of those slopes to find a slope that's perpendicular. So our slope formula, slope is equal to y2 minus y1 divided by x2 minus x1. So let's number our points again. x1, y1, x2, y2. And we'll plug them into our formula. Okay? So y2 is 6. Subtract y1 is negative 3. Divided by x2 is 8. Subtract x1 is 9. Slope is 9 over negative 1. So our slope is negative 9. Okay? And our other slope, number off our points, x1, y1, x2, y2. Remember our slope formula is y2 minus y1. So y2 is 6, subtract 5, divided by 8, subtract negative 1. We get 1 over 9. So our two slopes, we have negative 9 and 1 over 9. So we look back to our circle. We look back to our circle. The slope of PQ, so our slope, which we call M, is negative 9 over 1. And the slope of RQ was 1 over 9. Okay? So we have our two slopes. We have to find the negative reciprocals of those slopes. So what will the negative reciprocals be of each of these slopes? What's the negative reciprocal of negative 9? Okay, so the perpendicular line to this, we're looking for positive 1 over 9. And perpendicular line to that one, what are we going to be looking for? Negative 9 over 1 or negative 9. Okay? So the perpendicular slopes, we'll do in red. I know the slope to my new right bisector is going to be 1 over 9. And this one's going to be negative 9. So our new right bisectors, we'll do them in red. It's going to be some line like this. And another line like this. Okay? So we know those are going to create right angles here. And we got to figure out exactly where the center of this is. So we have our new slopes. I need to actually get the equations of these right bisectors. Okay? So let's go back down to where we had our slopes. Our equation of a line, if you guys remember, is y equals mx plus b. Now we have our new slope. Our new slope, 1 over 9x plus b. And for the other one, y equals mx plus b. Y equals negative 9x plus b. So let's just verify which lines these are. This is line QR. Sorry, this is perpendicular to QR. It's perpendicular to QR. And this is to PR, PQ. So perpendicular to PQ. These are the equations of the lines perpendicular to those chords. Okay? So we got to actually find the equation of and M1 because there are points on our right bisectors. We're going to plug them in. 1.5 is equal to 1 over 9, 8.5 plus b. We're finding the equations of these lines. We get 1.5 is equal to 8.5 divided by 9 plus b. We're going to multiply this entire equation by 9. 1.5 times 9, 13.5. Equals 8.5 plus 9b. 13.5 minus 8.5 equals 9b. What's that going to give us? 5?
Nope.
So our b is 5 over 9 equals b.
Well, I can't
So
see.
the equation of our line ends up being y equals 19x plus 5 over 9. $5.5 equals negative 9 times 3.5 plus b, finding the equation of our other right bisector.
It's not right. It's wrong. Sir, we already know where
31.5. We bring 31 over. We get 31.5 plus 5.5 equals b. It's going to give us 37 for b. So our other equation will be y equals negative 9x plus 37. Okay, we need to use substitution. So we're plugging in this because it's equal to y into our second equation. So we're going to plug that value in. 1 over 9x plus 5 over 9 equals negative 9x plus 37. Because we have two fractions of 9, we're going to multiply every term in the equation by 9.
And we're back to where we were.
We will get x plus 5 equals negative 81x and 37 times 9, triples. Constant terms on the right.
No! Why would you do that?
I would have solved that. Come on.
So you're making it right. That's not very good. So you're not supposed to make it right. This is not how the world turns.
That's going to be 328. Woohoo! X equals 4.
Damn it!
So the last thing we need to do is substitute that into an equation. We'll use our second equation. Don't worry. That's not that hard of a feat.
I don't understand this at all.
Plug 4 in for x. Y equals negative 9 times 4 plus 37. Y equals negative 36 plus 37. y equals 1. The center of our amazing circle is at 4 and 1.